Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Unlike traditional networks, cloud computing involves shared infrastructure, elastic resources, and service abstraction. These changes bring new risks and demand a rethinking of how security is applied and enforced. Whether managing identity, data, or networking, organizations must adopt cloud-specific controls to protect confidentiality, integrity, and availability. Understanding these implications is vital for both cloud adoption and exam preparation. On the Network Plus exam, cloud security appears under cloud computing and cybersecurity objectives. Questions may ask you to identify roles in the shared responsibility model, determine the best use of encryption, or troubleshoot misconfigured access control. You may also see scenarios involving segmentation, compliance, or detection tools. Understanding how cloud environments differ from traditional networks and what controls must be applied will help you answer these questions accurately and confidently. The shared responsibility model defines who is responsible for which aspects of security in the cloud. The provider handles the physical infrastructure, hypervisors, and core services. The customer is responsible for the security of their data, applications' identities, and workloads. These boundaries shift depending on the service model. Software as a service has more provider control, while infrastructure as a service gives the customer more responsibility. Knowing where the provider's job ends and the customer's job begins is fundamental to secure deployment. Encryption plays a key role in cloud data protection. Data should be encrypted both at rest and in transit. At rest, encryption is typically handled by the storage platform, often using AES 256. Customers may choose between provider-managed keys or customer-managed keys, with the latter offering more control but requiring additional setup. In transit, TLS encrypts traffic between clients, services, and APIs. Encryption ensures that even if data is intercepted or stored improperly, it cannot be read without authorization. Identity and Access Management, or IAM, governs who and what can access cloud resources. Properly configured IAM systems define users, roles, and permissions using the principle of least privilege. Roles should grant only the access necessary to perform specific tasks, and multi-factor authentication adds an additional layer of security. System identities like service accounts or instance roles should be tightly scoped to avoid lateral movement and privilege escalation in the event of a compromise. Network segmentation in cloud environments is essential for isolating workloads and minimizing the blast radius of security incidents. This is achieved using virtual private clouds, subnets, and access control mechanisms like security groups and network ACLs. Different tiers of applications, such as web, app, and database layers, should be deployed in separate segments, each with its own access rules. Segmentation ensures that even if one service is breached, others remain protected. Monitoring and logging provide visibility into cloud activity and are crucial for detecting security events. Cloud providers offer native tools like AWS CloudTrail, Azure Monitor, and Google Cloud Logging, which track user actions, configuration changes, and network events. These logs must be enabled, stored securely, and reviewed regularly. Integration with alerting systems and third-party security platforms enhances incident response and compliance monitoring. Visibility is a prerequisite for managing risk and auditing behavior across cloud resources. Misconfigurations are among the most common and dangerous security issues in cloud environments. Examples include publicly accessible storage buckets, overly permissive IAM roles, or unpatched virtual machines. These missteps often go unnoticed until data is exposed or an attacker gains access. Security reviews and configuration baselines help identify these issues early. Automated scanning tools can compare deployed configurations against secure standards and alert on deviations. Vendor lock-in and compliance pose risks beyond technical configuration. Relying too heavily on a single provider can make it difficult to migrate workloads or adjust to new regulatory requirements. Some countries have data residency laws that restrict where data can be stored or processed, which may conflict with default cloud configurations. Planning for portability and auditing legal requirements before deployment helps avoid costly compliance failures or service disruptions. Disaster recovery and backup strategies in the cloud must be clearly defined and regularly tested. Backups should be stored off-site or in different cloud regions to protect against local failures. Cloud platforms often offer snapshot and replication features to automate these processes. Recovery point objectives and recovery time objectives must be aligned with business needs and documented accordingly. Secure backup and recovery are key pillars of availability and business continuity. Zero Trust is a cloud network security design principle that assumes no user, device, or system is inherently trustworthy. All access must be verified continuously. Identity verification, role enforcement, session monitoring, and encryption are applied at every layer. By treating every connection as untrusted, Zero Trust architectures reduce the risk of lateral movement and help contain breach. This mindset is increasingly integrated into cloud platforms and should be understood conceptually for the exam. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Cloud net firewall services and intrusion detection systems play a vital role in maintaining secure boundaries within and around cloud deployments. Firewalls, at the cloud edge, filter traffic based on source, destination, port, and protocol, enforcing policy rules that separate trusted and untrusted networks. These filters can be applied per subnet or per virtual machine and are often implemented as security groups or network ACLs. For internal visibility, intrusion detection and prevention systems can monitor east-west traffic, movement between cloud resources, to detect unusual patterns, known attack signatures, or unauthorized data transfers across segments. Secure configuration management ensures that systems are provisioned with the correct security settings from the start. Templates used to create cloud environments should comply with industry standards and organizational policies. Image hardening ensures that virtual machine templates exclude unnecessary services, enforce strong authentication, and have security patches pre-applied. Policy as code tools allow teams to define acceptable configurations in version-controlled files and enforce them automatically. This approach helps prevent configuration drift and supports consistent security across environments. Shadow IT is a growing risk in cloud environments. It refers to the use of cloud applications or services without formal approval or oversight. Employees might use unapproved file sharing, communication, or development tools that bypass organizational security policies. This lack of visibility can lead to data loss, insecure data sharing, and compliance violations. Organizations need to monitor network traffic for signs of unauthorized services, implement cloud access security brokers, and educate users about acceptable use to reduce this risk. Application Programming Interface or API security is especially important in cloud environments where services are exposed over public or shared networks. Each API must be secured using access keys, scopes, or tokens that restrict what clients can do. Rate limiting helps prevent abuse or denial of service attacks, while API gateways add a filtering layer that enforces policies and blocks malformed or unauthorized requests. Logs and metrics from these services support incident detection and help ensure that each API call is legitimate, traceable, and within acceptable usage limits. Penetration testing in the cloud must be approached differently than in on-prem environments. Because cloud infrastructure is shared, unauthorized scanning or exploitation attempts can impact other tenants. As a result, cloud providers require customers to request permission and follow specific guidelines before conducting any tests. These permissions define which parts of the system may be tested and what tools or methods are acceptable. Tests may cover web applications, cloud networks, or virtual machines, but must be scoped carefully to comply with provider policies and ensure ethical use. Legal and regulatory considerations often shape how cloud environments are configured and managed. Regulations like the General Data Protection Regulation, or GDPR, apply strict rules on where personal data can be stored and who can access it. Healthcare providers may also fall under HIPAA, while financial organizations may follow PCI DSS. Cloud providers support compliance through audit-ready logs, access controls, and location-aware services, but it remains the customer's responsibility to configure services in a compliant manner. Knowing the data's jurisdiction, encryption status, and access controls is essential for regulatory success. Cloud Access Security Brokers, or CASBS, are tools used to monitor and manage cloud service usage. They sit between users and cloud applications to enforce security policies across platforms. A CASB can detect when an employee tries to upload sensitive data to an unauthorized cloud service, alert administrators, and block the transaction if needed. They also provide visibility into sanctioned and unsanctioned cloud use, help enforce encryption, and support compliance through detailed reporting. CASB solutions are especially useful for detecting and managing shadow IT behavior. The Network Plus exam includes questions that cover the boundaries of the shared responsibility model, the importance of encryption and access control, and the risks associated with misconfiguration and shadow IT. You may be asked to evaluate a scenario involving improper access control, select the correct identity mechanism, or determine how to segment workloads across virtual networks. Understanding how security tools integrate with cloud services and how responsibilities are divided between the provider and customer is essential for passing security questions on the exam. Cloud computing introduces new ways to deliver services and store data, but it also introduces new risks that must be addressed through a combination of platform features and customer responsibilities. With tools like CloudNAB firewalls, automated configuration enforcement, identity and access management, and secure API controls, organizations can create resilient and compliant environments. By understanding the unique security implications of cloud computing, you'll be better prepared to design safe environments, respond to emerging threats, and succeed on the Network Plus exam. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.